Hello everybody, my name is Ben Brady and I am the 3D Printing Texan. Today, we're going to do a video. I don't know how long it's going to be, but it's going to be long. So buckle yourselves in. We are going to upgrade my Ender 3 to an MKS Gen L board. And so I'm going to go into all the details, try not to leave anything out. We're going to do an MKS Gen L board with TMC 2100 drivers because that's what I have on hand. I have some A4988s, but we're going to use the 2100s so that we can go through the Marlin configuration, and we're just going to do it all. And then I also have, and I may split this up into two videos, a TFT 28 color touchscreen to go along with this board. I got to do some programming on the screen, so that probably is going to end up being another video because I have a BLTouch on the Ender, and the TFT doesn't have the commands in the firmware currently for the BLTouch. So I'll have to do some programming and show you how to do that. All right, so we're going to go to the various cameras, and then I'm going to switch off. I'm going to go over here to the bench for a little while. And but first, what we have to do is we have to configure the board. Now, let me switch over here to my desktop view. Let me find my cursor. Hello, Mr. Cursor. It's like these cotton-picking wireless mice. I don't know. All right. I'm going to turn some lights on here so we can see. And you're going to get a little washed out, so I'm going to go ahead and transition over to the desktop camera. And let's see if we can find a good angle for the light here. And you're not going to see me talking because the light has my webcam pretty much washed out. So I'm going to voice over the video, and you'll get to see my smiling face a little bit later. All right. So what we have here in the picture is an MKS Gen L board, and you can see that's what it says, MKS Gen L board. And I have already mounted this in the case that I'm going to be using for my Ender printer. Now, let me grab the other case so you can see. I printed two of these, and let me just kill the light a little bit here and switch to the other camera. I guess I'll leave the light on. Now, this case was originally developed by Michael Laws down there in Australia. He has a YouTube channel called Teaching Tech. And his case, his original design, made some assumptions that I didn't like. And they just didn't seem like they would work for what I wanted to do with this board. So the first assumption that he made was, and I'm not picking apart his design. He did a good design. I just made it a little better. So, and I have redrawn this whole design in Design Spark Mechanical. And if y'all want the files, I'll put the files up on Thingiverse, the STL files. But if somebody wants to modify this design further, just contact me in the comments and I'll send you the files. So this design holds the MKS Gen L board, and Michael made a few assumptions. So this design will work on an Ender 3 or a regular Ender 3 or an Ender 3 Pro. Now on a regular Ender 3, the box mounts upside down like this, okay? And so this panel here goes over on the left-hand side of the printer. as does the panel if it mounts the other way. But if it mounts the other way, then the top opens up like this on, and this is on a, this is for an Ender 3 Pro. Okay, so this will work on either printer. Now, the board, when you mount this case, the board will mount like this, and this top part will go up. Okay? Now, the problem that we have with this is, the original design, is there wasn't any way to really attach the fan that is used to cool the stepper drivers. So what I did was I modified the design to use some fan screws to mount the fan. And they go all the way through. What I did was I went ahead and, let's see if I can get a good angle on this. So I went ahead and I created a little pocket for the fan to fit in, and the screws go all the way through so that you can anchor the fan. What Michael had done worked, but what he had was on this little lip right here on the lid, he had a little bitty nub of plastic that would just kind of bounce up against this edge and keep the lid from going any further. But the other purpose was to keep the fan from falling out the hole. And so that just didn't seem, that was just a little hokey for me. So I went ahead and I redesigned this thing and I redrew it. The other thing that he had was these little tabs that go into the extrusion to keep it closed. Every time I printed it, they broke off. Every single time. I don't know why. They just wasn't good. And the hinge pins on either end of the hinges here would break off. So what I did was I went ahead and I redesigned the whole hinge. I put a cutout here in the hinge for the video cable to go through, because that's where it goes out. And this just makes it a little bit nicer for mounting the board. Okay, so I printed 2 of these because I have a friend of mine who has an Ender 3. He wants me to modify as well, so I figured I'd go ahead and print one for him as well. And it was an interesting project because doing design. I also have one here in purple. Because I had some purple filament at the time. Maybe you can see this one a little better. Just made it a little nicer. Made it a little nice fan grill for the fan, and I like making things a little nicer. This gets little strings on it. So anyhow, I printed this several times and made it nicer, and it fits my purpose. All right. Now, so that's that. So what I did was I went ahead and mounted this in the box already, because you don't need to see me futzing around with screws and dropping Allen keys. Let me make one suggestion in your workspace. Let's see. This has some stuff on it, but I'll show it to you in a bit. Get yourself a carpet square, 1 foot by 1 foot carpet square, and put it on your desk, on your workspace, if you have a hard table, for a couple of reasons. First of all, to protect your table. Secondly, if you drop a screw, it won't bounce on the table and onto the floor. Now, here in my room, I have a carpeted floor. And I can't count the number of times I've had to search on my hands and knees for a screw in the pile of the carpet, because screws, for whatever reason, they have this tendency to fall where the least cross section of screw is visible from above. So it makes it difficult. And I use flashlights and all kinds of stuff and magnets and what have you. Some screws are magnetic, some screws aren't. So get yourself a carpet square and put on the desk. My wife found some carpet squares for me, but they're 2x2, and so they don't fit on my desk. So I'm going to have to cut one down. All right. Now, that being said, let me go ahead and switch cameras here because we're gonna do some other stuff here. So this is the MKS Gen L board, and we've got a few connections that we're going to make here. But the first thing that I'll tell you is I bought this board about let's see, 2 months ago from, let's see, I think I bought this one from Fistech. And I think they're out of New Jersey. They have a warehouse in New Jersey. So the firmware that's on this board is Marlin 1.06. Now I know this because I hooked up the board to Pronterface, and I'll show you how to do that, and did some interrogation in Pronterface to find out what status of the board is. Now these boards have an Atmega 2560 processor, and so they should already have a bootloader on them. If they don't, of course, you can always burn a bootloader to it, but more than likely it's already got the bootloader onto it. We'll have to do a test to make sure. The only way to test for a bootloader is to try to update the firmware via the USB port, and so we'll do that. That's our first step, is making sure that we have Marlin configured for the board to go into our Ender 3. So we're going to go through that in this video. Now you'll notice, let's see if I can find something here to point with. I've got some dental, some hemostats here. All right, so these areas here are where your stepper driver goes, and there's 5 slots here for the stepper drivers, and typically you have X, Y, Z, and your extruder, and then you have another driver for another extruder if you wanted to do dual extruders. Now, you can do that. The other thing that's available here is we also have extra pins for dual stepper motors, let's say. So, for example, if you have a printer with a Z axis that has 2 Z motors, you can plug the first one here, and you can plug the second one on these pins right here. Okay, and that way both Z motors will be accessed at the same time. Now, for our sense of purposes, we are going to do an Ender 3 with 1 extruder, and who knows what may happen in the future, but for now, we are going to do just a standard straight 1-to-1 install. So now we have, let's see, your power inputs here, 12 volts, 24 volts. Your heated bed goes here. Your heater for extruder 0 goes here. Your heater for extruder 1 goes here if you have another extruder. And then you have the outputs for your controllable fan. Okay, so that would be your part cooling fan. And then over here, we have the output for 12 volts, 24 volts. And this would be typically used for your hot end cooling fan. And then, or typically your stepper driver fan could also come off of there. So that we have your stepper drivers here, and then we have over here we have your X, Y, and Z end stops. So we have min end stops and max end stops. And then we have plugs for your display adapters and plugs for the TFT display and your servo pins for your BLTouch or maybe some other filament out sensor. And then we have your thermistor for the bed and 2 hot ends over here. So, and then of course we have your USB input. I'm backwards here. Your input goes right here, and it's just a regular standard USB-A interface, just a regular USB cable like you'd have for your normal inkjet printer. So now, what's missing from this board is the SD card interface. Now, you can buy an SD card interface that will plug onto this board, and it'll go into one of the auxiliary pins here. You can also buy a Wi-Fi adapter that will go onto the board. Now, what we're going to do is we are going to modify the printer to use the TFT, either the 28 or 30 or the 32. I have both boards, probably the 28, and the 28 will allow you to either use an SD card or a USB flash drive. And so either one of those, you could put STL files on the flash drive and send them to the board. You can plug the Wi-Fi module into the board, and you can send the STL files from over Wi-Fi to the display so that you can print. So there's a number of different ways that you can get there. Okay. Of course, you can always plug the USB into the USB port into an Octoprint and print that way as well. So there's all kinds of different ways to do this. But for today, we're just going to upgrade the board and probably just get the Ender display working for now. And then in the next video, we'll do the TFT display. So let's see. First thing we have to do is I'm going to show you, and the reason I mounted this board in here, aside from you not having to watch me fiddle with screws, is it just makes it easier and safer to move the board around and do what I need to do without shorting things out and touching things that shouldn't be touched. So the first thing we're going to do is we are going to take our USB cord and we are going to plug it into the side here. And you're going to see some lights flashing right here. Let's see. Let me get it into the shot. Right here, there's some lights flashing. It's on the other side of the USB port here. Let's see. Can we get there from here? Right there. You can see the reflection of the light from my fingers. Okay, there we go. So there it is. It's on. It's powered up. It's receiving signal from the PC. And I'm dealing with older desktop cameras here, so please bear with me. Now, I'm going to switch. Some of you may have seen my other video for my Microsoft VX5000 modification. And let me kill some light here a little bit. Do some adjusting of the light. And transition to that one. So there's my my VX5000 camera, operational in the housing, working like a champ. Unfortunately, there's no zoom, so I can't zoom in, but this gives me a desktop view, overview, wide-angle view, and it's working fine. So it's up on a GoPro Go Stick tripod, and I'm going to have to get a little smaller tripod to bring it down to get a better angle on some stuff that I'm doing. Maybe I'll get one of those little Targus flexible gorilla tripods or whatever they're called. But I've got one on another camera. It's pretty handy. So so what we're going to do is we're going to open up Pronterface, and I'm going to show you how to interrogate the board. So let's see. I got to find my display capture, and I usually have this set up on a switching deck on my tablet, but right now I'm not connected with the tablet. So I'm just rearranging the screens here so we can see. And let me move this out of the way. And then I will go to here. Now, this is Pronterface. And the first thing that we want to do is we want to make sure that we have the correct port for the cable that's plugged in to the board. So the first thing we're going to do is I'm going to come over here. I'm going to grab this. I'm going to come over here, cover that up for now. And this is Device Manager, for Windows Device Manager. And so we're going to come down here to the ports, and we can see here it's USB serial CH340 COM14. That is our board that we have plugged in. Now, if I unplug this board, you're going to see that port go away. Okay? See, it's no longer there. So that's how we know it's the correct port. So we're going to plug this back in, and you're going to see it pop back up, and here it is, COM port 14. All right. So that tells us what port we're going to use for Pronterface, because we can have several ports show up in Pronterface depending on what we have plugged into the computer. So we're going to go ahead and kill that. Now, if you're moving from an Ender 3 or some other Creality printer, you're going to come up here and you're going to select the COM port 14. In my case, it's 14. But the baud rate is going to be set to 115,200. That's if you've connected with Pronterface before, with your Creality printer. This board operates at 250,000. So change the baud rate to 250,000 instead of 115,200, and then hit the connect button. And what you're going to see is you're going to see a bunch of stuff come over here on the side. And let's see. I don't believe I have a way. I'm going to have to set that up. I'm going to have to set up a zoom somehow to see if I can zoom into this side of the text. Okay, because I know on your side it's probably pretty darn hard to read. So what we're going to do is it goes through the initialization of the board, does some things. So what we're going to do is we're going to issue a command. Now we can see that the board's powered on. It says the printer is now online. The last update for this board was August the 7th, 2015 at 11:42 a.m. There's no author configured, and the free memory is 3241, and the planner buffer bytes is 1232 bytes, and it's got the hard-coded default settings loaded, and then it gives you the steps per unit. So the X is 78.74, the Y is 78.74, and the Z is 533.33, and the extruder is 836.00. So we know that those settings are going to change. So, and then we've got maximum feed rates, and we've got maximum accelerations settings, and then some advanced variables, minimum feed rate, minimum feed rates, and home offsets 000, and then PID settings, which will change because we'll have to do a PID auto tune, and then it gives an error message of error 0. Now, since we don't have any end stops plugged in, and typically these boards use 5-volt based end stops, it says that the min temp is triggered, and it says the printer has stopped due to errors. All of this is fine, normal stuff. Don't worry about it. That's all going to change once we get the printer hooked up and their cables attached and what have you. So, but what we want right now, and then the other thing it says down here is SD init failed. That's because there's not an SD card. All right. So the first thing we want to do is, and then the other thing that we wanted to find out here is, where is it? It does say here somewhere. Oh, here it is. Right here it says echo Marlin 1.02. 1.0.2. That's the version of Marlin that is on this board by default. So we know for sure that we need to update this board. So we're gonna update it to Marlin 2.0. So that's how you find out what's on the board. Now, you can go down here to the entry, and you can type M115, and that's going to give you this information that says firmware name Marlin version 1.0.2 Sprinter Grable markup for and then a URL for the GitHub for Marlin, and then the machine type is a Mendel extruder count 1, and then there's a thing called uuid. That's a uniquely unit identifier, and you can go to a website and you can generate that number that is unique for your printer. No other printer in the world will have that identifier, and that can be used to control printers over a network and things like that. But right now it's set to 0. So and I'll show you a place in Marlin where you can set that. All right. So that's how you do this in Pronterface. Now, Pronterface is also called print run. So either way, if you Google Pronterface or you Google print run, you're going to get to this application, and it doesn't come with an install program. You download it and you put it in a folder, and then create a shortcut on your desktop to that program in the folder, and then you can run it from whichever way you want to run it. Okay. It's a very simple program, and you can actually print files with it. You can control your printer with it. You can do your XYZ homing and what have you. You can specify temperatures. You can extrude filament. You can load the file. You can load the SD card. You can control all of your printer through here if you want to. So this was how people did it a few years ago. But it's still a very worthwhile utility to have. Many people still use it. All right. So we're going to go ahead and switch back to the camera here. And let me turn that light out and transition back here. Now, what we're going to do is I'm going to get things set up with the Arduino interface while we're talking, and I'm going to show you how to go from an Ender 3 configuration for Marlin to the configuration that you're going to need for Marlin to run this board on an Ender 3. And so it just takes a moment to come up, and I need to move some things around here because I don't have my configuration file set up the way I need to get it set up. So let me kill that. And, excuse me, bear with me just a moment while I copy some things. And it's been an interesting day so far. Went and had breakfast with a friend of mine who has an Ender 3 that I'm going to modify. And then he bought an Ender 5 and he hasn't put it together yet. Let's see. So we're going to go. I'm going to show you how to do this stuff. Let me switch back to the desktop. So we'll go here, and I have all of my firmware. I have all kinds of firmware here set up, and so I like to use the Tiny Machines firmware. Dave Menzel is a really good developer, and he knows his stuff, and so I trust his builds. And so we're going to go into the Marlin bug fix, and then here's the Marlin folder, and I've got a couple of example configurations already set up. When you download Martin 2.0, you will not have example configurations. They don't exist yet. Marlin 2.0 is still in development. It's in that nebulous area between being released and not being released yet. So, but for 8-bit, for standard 8-bit controllers like the Gen L board, the Marlin 2.0 firmware is very, very stable. Basically what they did was they took the 1.1.9 build and they forked it and they made modifications and they refactored the code to fit into their new development paradigm using Platform IO and Visual Studio Code. And so rather than use the Arduino IDE. But now you can still use the Arduino IDE to do things. It's just a lot easier with Platform IO and Atom and Visual Studio Code. So I've got a couple of example files here, some mostly Creality stuff because I have Creality printers. I've got one for Tevo Tornado there. So we're going to go into Ender 3, and I've got an Ender 3 with a BLTouch 2, but I've got my custom configuration here, so that's the one we're going to use. So I've got 3 files here: the boot screen and my configuration files. So we're going to go ahead and copy those, and we're just going to come back here to the Marlin folder and copy those into there, like so. All right. So now we're ready to open up the Arduino IDE. So we go down here to this file that says marlin.ino. And when we double click on that, that's going to launch the Arduino IDE. And we are going to get a window here with that up. Now, because the code has been refactored and set up for use with Platform IO. It used to be when you opened Marlin up in the Arduino IDE, you would see a whole bunch of tabs across the top, and over here there's a drop-down arrow, and you would see a whole bunch more modules down this list, and it went forever and ever and ever. Now what you see are the Configuration H tab, the Configuration H Advanced tab, the boot screen tab, and the status screen tab. That's it, because that's all of the source code that is in this folder that's visible to the Arduino IDE. So let's look at a couple of things here. I'm just going to go ahead and scroll down a little bit, and here is where you can create your own Marlin bitmap. This is the URL. I'll highlight this so you can find it. And that gives you a way to make your own custom boot screen, splash screen. So when the printer starts up, you can see that my splash screen has my BEB3D logo. Now, there's some splash screen widths, and this is the splash screen stuff. So now what we're going to do is we are going to go back here to the configuration H tab and scroll down, and the first thing that we're going to look for, so here is my define for the author of this configuration file. And so in my case, it's Ben Brady, Ender 3, and then show the boot screen and and define the variables for the splash screen, and then show the custom boot screen because I made one, and I commented out the custom status screen because I didn't like that custom status screen, so I'm just using the stock status screen. All right, serial port 0. Now the very first thing we're going to do is we're going to change the baud rate. So the baud rate for this board is going to be 250000. Okay, so that's the first thing you want to change, is the baud rate. And then the second thing is you want to change the board name. Now, how do you find the board name? Well, there's a couple of different ways that you can do it. You can watch a bunch of YouTube videos, but that's not the easy way. The easy way is to go, once again, go into your folder and go into your source folder and go into, I believe it's the pins folder, and it may not be the pins, but let's look and see if it's in the pins H. Actually, we can find it if we go down here. We can see the MKS Gen, let's see, there's MKS Gen L right here. So it's going to be MKS Gen L is going to be the board name, because that's the name of the board in the pins. So that's one way to find it. Now the other way to find it would be to go back to the source and back to the HAL. I believe it's in the HAL. No. Libs, module, SD. Let's look under module. No. Include. Nope. Core. Boards. Here it is. It's into the core folder, and it's the boards H file. So if we go here to the boards H file, and I'm going to go ahead and send that to my editor so we can do a search. And don't use Windows Notepad for this. Use a real programming editor, like Notepad++, or in my case, I use EditPad Pro. So what we want to do is we want to see what this board is named. So in this case, it's board MKS Gen L. Okay, so what we want to do is we want to copy this to the clipboard. Just double click it, copy it, however you highlight your board name, and then go back here to the Arduino IDE, and instead of this saying board Melzi Creality, we're going to make it say board MKS Gen L. All right. Now what that's going to do is that's going to allow the compiler to understand what board we are compiling for. All right. Now the next thing we want to change is this custom name, and I make mine say BEB3D Ender 3. You can make it say whatever you want. Now, remember we were talking about the uniquely identifier, the unique unit identifier. Say that 3 times fast with false teeth. By default, in the firmware, it's set to all zeros this right here is the website that you will go to generate a UUID. So if we go here, and it's already linked, I'll go ahead and pull it up here and pull my browser over here. So here is, we come to this page, and then based on our browser and our session ID and the time and the date and what have you, it comes up with this number right here. Okay? And this number is unique to this instance of the browser ever. It'll never be duplicated. So you say copy, and it comes back and it says that it's copied to the clipboard, and then we can go ahead and come back down here. And in this case, I'm just going to go ahead and copy this right in here with a Control V. And so now, if I want to enable that, I can just uncomment that, and this machine with this board, with this firmware, will now have that ID that is unique in the world. All right. Now, that's how you do that. Kind of handy. Then we have number of extruders. 1, default nominal filament diameter. By default, Marlin is set to 3.0 millimeters. So make sure you set this to 1.75. Now let's go down here. We don't have an MK2 multiplexer, and let's see. We have a dual. We don't have a dual nozzle. We don't have a parking extruder. Let's see, what else do we need? We don't have a switching tool head. Where else do we need to go here? We're going to use the stock thermistors, the stock temperature sensors, the stock hysteresis and temperatures. Now, I believe we may have to change the direction of the steppers, because either Creality does them backwards or TMC does them backwards. Either way. And you can find out when you put your board in and you start testing, if your X or your Y go the wrong way, just go back in here to the firmware and change the direction. Of course, we have our PID auto tune settings here, and when you do your PID auto tune, it'll tell you, here's the default values that you should use. Go ahead and update them in your firmware. This is where you put them. Let's see, bed heating, bed limit switching, prevent the cold extrusion. Now, let's say, for example, for some reason you have a situation where you want to be able to extrude, use your extruder at a lower temperature. Let's say, for example, let's say you're doing wax filament for lost wax models. Let's say you're making jewelry. You can go here and you can change it to, I think the wax probably melts at like 130 degrees to do your extrusion. So you can change it right here. The default temperature is 170. They claim that it's a safety issue. Okay. That's fine. Here's the thermal protection. This is enabled. Thermal protection for the hot end and for the bed, and for if you have a heated chamber. Let me see here. Do we need that for the heated chamber? No, I don't think so. I don't think we need it for a heated chamber. We're going to comment that out, because we don't have a heated chamber. Maybe that's a source of some problems. If you have a Core XY machine, here's how you define your Core XY machine. And then end stops. So in the ender case of the ender, we use X, Y, and Z min. And then we have pull-ups and then we have pull downs, and then we have inversion. So in this case, what we have here is, because I'm using the BLTouch, this setting, end stop inverting, is true. If you're just using a regular end stop switch, this would be set to false. If you are using a probe like the BLTouch, this Z-min probe end stop inverting is also set to true. Okay, so both of those have to be set if you're using the BLTouch. Now stepper drivers. Now right now it defaults to ANET, the A4988. I don't know why I keep trying to say ANET when I say A49. But so in this case, I have TMC 2100 drivers. So that's what we're going to use. So I'm going to come over here, copy that. And for all the places that I'm going to be using these 2100 drivers, so we have the X and the Y and the Z. We don't have a second extruder or a second X motor or a second Z motor, so we'll just leave those commented out. By default, Marlin defaults to the A4988 in other places in the code. So, but here, if you're changing them, you have to go ahead and uncomment these lines. So we have the X, Y, and Z, and we also have the extruder. So because in this case, I'm using the same for the extruder. Now, I have a fifth driver, and at some point I may try playing with dual extruders, but for now I'm just going to leave this commented out. But I will change it. But as you can see, it's commented out. Now, I don't know if these pins are interrupt capable, so we'll just go leave that there. And then let's see, what's the next thing we have to do? So we have our drivers all set, TMC 2100s. And that's the important part. And then here's our place for the steps per unit for the axis. And by default, the Creality stepper motors are 80, 80, 400 for the extruder, and I'm sorry, 400 for the Z, and 95 for the extruder. So I'm going to leave those there for now until I recalibrate, because we will have to recalibrate our E-steps, our steps for the X, Y, Z, and extruder. So we'll just run down here. There's the max feed rates, and the max acceleration, and default accelerations. Now, this is the new area we're going to get into. Since we have more memory on the board, we can enable some new features that allow for some much nicer prints. For example, junction deviation. We're going to go ahead and enable that. Excuse me, got the hiccups. We'll leave the jerk settings to the default. We may need it later. And now we have another new feature called S-curve acceleration. We're going to go ahead and enable that because we have memory to do that. And of course, some of these things will need some configuration. And now we have probes. So because we're using the probe, the BLTouch probe, and it uses the Z-min probe end stop, this is defined as yes. Typically, this is commented out in the default of Marlin. But like I said, this configuration was already set to use the BLTouch. Now, I'm not sure if this board uses pin 32. So I'm going to have to look this up to be sure. Then we have probe manually. That's if we want to do manual probing on the bed. And then we have fixed mounted probe, servo probe. So in this case, we have BLTouch. Now, on my Ender 3 currently, we have a BLTouch version 2.2. So we don't typically necessarily have to enable this delay, but I currently have it set at 100. So, I mean, it could be, by default, Marlin defaults to 300. And in the Ender 3 configuration examples, it says to set it at 375 and increase it if needed. But that's because there's a capacitor on the board that causes all kinds of issues with the ZN stop. All right. Here is the new settings for the BLTouch 3.0. If you get a 3.0 probe, the default setting you want to set is this one right here. Define BLTouch force 5 volt mode. Excuse me. That's the one you want. Now, the other thing that I'm going to have to find out is, of course, currently we're set to pin 27. That's for the Creality board. That's the same board as the beeper. And I believe we really need to reset this number, and I'm going to have to find out what that number is. So when I pause the video to do some things to get ready for the next segment, I will find out what number is supposed to go there. Now, I know on the Creality CR10S, that number is number 11. But it could well be that they use this pin 32, which is this guy here. That's the ramp's default. So I got to find out if they use pin 32. And if so, then we just comment that line out or change it to pin 32. Or whatever the servo pin is. So from here, it could be pin 4, as a matter of fact. I think I recall seeing something about pin 4 somewhere. So I'll have to look in the code to find out. Let's see, and then we have our probes, offsets for the mount for the probe. Yeah. In the stock BLTouch mounting that you get on Thingiverse, it's -40 because it mounts on the left-hand side of the extruder, and -5 because it's a little forward of the nozzle. And then, of course, the Z is 0, and then, of course, the minimum probe edge. Now, in the stock Marlin, they've reduced the probing speed to 8,000. I went ahead and bumped it back up to 10,000 where it used to be. And then I use fast homing and then slow homing for the second probe. And then if you want to do multiple probing, it slows things down, but it makes things a little more accurate. You can uncomment this, and it will average the results and makes things a little more accurate. So now we have some probe clearances, and then the Z height after probing. I've got it set to 5. Typically this is commented out, and you end up at 10 because that's the default. Now, M851. Those are the settings for the Z probe offset min-max, -20 and +20. Now, we can enable the M48 repeatability test. We can enable that and make that test available in the menu. And then we can also confirm the deployment of the probe. But I typically don't turn that on. If you have a capacitive probe, You want to turn heaters off while you're probing. For the BLTouch, it doesn't matter. It actually should be on. But for capacitive probes, it could be an issue because capacitive probes tend to be a little prone to interference from the heaters. And then fans on or off. And then here's where you do your inverting for disabling the steppers while you're probing. Okay. Now, this is where if you find your Z and your X and your Y are going in the wrong directions, this is what you have to change. Now, Creality typically inverts these. Okay, so that's why these are set to true. So I'm going to change these to false because Creality does it backwards. If I find in my testing that the motors are running the wrong way, I can come back in here and I can change them. All right. Now, no motion behind foam. Now, no, unknown Z, known ray, no rays. Okay. Let's say you've just turned your printer on, and let's say you had a print fail. Let's say you did a big print, 40 hours print, and it failed at the very top of the print, like within the last 10 millimeters of your Z height, for example. And so you turn off the printer. You kill the printer. Now your Z is all the way at the top. When you turn the printer on, it's going to try to, when you do your home, it's going to try to go up. And then to find out if it's on an end stop. And then, because it doesn't know, the printer is dumb as a box of rocks at that point, you're going to want to find out where you're at in the world of the 3D printer. And so, if you have this set, it won't raise the Z if the Z is unknown. Okay, if there's no value in the Z, if on the display it shows a question mark, then it's not going to raise the Z to find out, or lower the bed. Okay, sometimes that's useful. And then define the Z homing height, and that's the minimal height before homing for G28. Now, I don't know what the default is, but this allows you to set it to 4. And then, of course, here's the direction of the end stops, and then here is the size of the bed. For the Ender 3, the bed physically is 235 by 235. The printable area is a little smaller. Creality says 220 by 220. In practice, 225, 230, very seldom would you get 235 if you're lucky. But if you set this to 235 and you set your print settings in Cura to 235, everything ends up on the center of the bed, which is what you want. Okay. So now we have your min and your minimum positions for your travel limits, and then your max for your Z. In this case, the Ender 3 is 250. The Ender 5 is 300. It's actually 305. And then, of course, we have software end stops. And these are turned on by default. And when you're doing your when you're setting your Z offset, you have to manually set them off so you can go below 0 if you need to. All right. Now, filament runout sensor, we don't have to worry about it with the Ender 3, but because we have this board, we can add a filament runout sensor. So, just have to find out what pins to use. And then the filament runout distance. let's scroll down here. This is auto bed leveling. I have bilinear set up because I have the BLTouch. And then restore leveling after G28. Now, typically when you do a G28, it wipes out the settings for your bed leveling by default. If you don't want those to get wiped out after you do a home, for whatever reason, this is where you turn this off. What I do is I typically will do a G28 when I first initialize the printer. I have it set up for Octoprint to do the G28 and set my leveling statistics for the bed. I go ahead and I scan the bed with the G29, save those to the EEPROM, and then when I start my print, I do an M420 S1, and that reads it from the EEPROM and enables the bed leveling so that the bed leveling is turned on and in effect. And then, so here's some more stuff about bed leveling. Here is the max number of points. I do 5 points, which is 5 points across the bed, 5 points down. So that's a total of 25 points. If you set it to 3, you get 9 points. Don't set it to an even number, like 4 or 6. It doesn't like that much. And then there's the probe edge things. And some more bed leveling settings, grid max points, what have you. Some of these are for mesh bed leveling, for manual leveling. And then some settings for the LCD bed leveling. If you decide you wanted to do the LCD bed leveling to like level the 4 corners of the bed using points, you can go ahead and enable that. And then of course it enables the edit menu. Level the bed corners. And then define the center level 2, move to the center after the last corner. So we'll go ahead and we'll turn that on as well. All right. Now, then here's the probe end script. This would be the script in G-code that would run after the probing is done. So in this case, it's telling it to move the Z to 10. This is probably absolute addressing, and it uses the speed of 12,000, and then another command, which is the new line right here, and then X to 15, Y to 330, which this 330 would be way off the range, so we would say 230. That would put it at the corner, and then another new command, new line, G1, move the Z to 0.5, and then another command to move the Z up 10. So there you go. If you want to run that, you can. This is how you send script to the printer, okay? You put it in quotes, and of course there has to be a place that you call for the script in another part of the code. But this is how you do it. You put it in quotes and you do /n for new line to give, so you can do multiple lines of G-code in your commands. Now, center of the bed. And then the thing that we really want is Z-safe homing. This allows you to make sure that the probe doesn't home off the edge of the bed and cause a problem. So just uncomment this. By default, it's commented. By default, when you home, it's going to home at X0, Y0, which is at the front left corner of the bed. So if you comment this, it is going to center the bed, put home at the center of the bed, rather. And then, of course, here is your homing speeds. I increase these to make it faster because by default they're slow. And then to validate the homing end stops. All right, now the rest of this is skew configuration. We don't need to mess with that. And then we have some extra things like the EEPROM, chit-chat, what have you, and M500 and things like that. All right. Now, there is a free memory watcher. I've never messed with it. I don't even know what it does, but it's there. I'll have to find out from Scott Latine exactly what it does. I'll send him a message. And then, now I typically change these settings. These are your menu settings that show up in your menu for your temperature, preheats. I usually set the label for PLA at 210 with a bed of 60 with a fan of 255. And instead of ABS, because that's what's usually set here is ABS, I set it to PETG because I don't print ABS unless it's in my DaVinci printer because it's enclosed. Now, the reason I don't print ABS is not that I have anything against ABS. As a matter of fact, I have some ABS right here in the drawer. I have parrots. And if you're printing ABS and you're not in an enclosure, you can kill the birds. So just make sure that if you're in that situation, that you are printing in an enclosure. And, if possible, a vented enclosure that's vented to the outside. Because you don't want to be in there breathing that stuff either. It is carcinogenic. All right. So here I typically set the label, the PETG, the temperature to 240 and the bed to 80 or 85, depending. I typically start at 80, but I find that I usually end up printing PETG at 85 on glass. So that's that. Nozzle park. I enable nozzle park by default because it's used by filament change. But I do modify the park point. Okay, so I in this case we had min position plus 10, my min position plus 10, and I can't remember what the I think the 100 is the Z position. So yeah, it is. So raise the Z to 100. Now that might be a little extreme in some cases. I can't remember. I think the default is 20, but I changed it. And then of course we have the feed rate, which is this how quickly it gets back and forth there. All right. Oops. Let me hit the home key. Get back here. Now, there is a clean nozzle feature. I've never used it, but it's here if you want to turn it on. And basically what happens is when you start your print, it's going to do a couple of little zigzags on the bed to make sure that the nozzle's clean, and you don't have drool hanging from the nozzle when you start your print. That's what it's for. All right. Print job timers. By default, the print job timer auto starts, and then we have a print counter. Now, in the Ender 3, the print counter is disabled. Since we have a board with more memory, we can enable it now. And that keeps track of the number of prints, failed, successful, or what have you. Now, let's go into the display settings. LCD language is English, and then there's the character set. Now, by default, every time I've seen Marlin, this character set is HD 44780, and it's set to Japanese. I set it to Western, so that way I know it's there. LCD info screen style is 0. You can either have 0, which is the classic, or you can have the Prusa style, which is a little different. It lays out the information a little differently. SD card support. Now, Since we don't have an SD card on this board, but it is on the display, we could get an error if this is turned on, if we don't have the display set up. So we'll see. I'm going to leave it turned on because by default it's turned on in the Ender 3. We can do an SD check and retry. Now, in the Ender 3, in Marlin 1.1.9 and 2.0, typically you have slim LCD menus turned on. Well, with this board, we want them turned off. So we're going to go ahead and comment that out. The encoder settings, we may want that different. We'll have to find out when we hook up our board. You need to understand that configuring Marlin for a new board may require more than one shot, okay? But it's not a big deal. You go through, you do your tests, you make sure everything's set the way you want it. If it's not, you can always just go in and change it and reflash. So it doesn't take a lot of time. All right, now you can reverse the encoder direction if you find your knob is going the wrong way. For navigating the menus. Define speaker. Now, define speaker and buzzer. If you're using a BLTouch on an Ender 3, you turn this off. You comment it out. So, but on this board, we're going to want it. So, because if you don't comment it out, on the Ender 3 and you're using a BLTouch with a pin 27 board, which disables the speaker, the little buzzer on the display, every time the probe probes, it will beep. So that's why you change this. So, but I want sound on my printer, so I'll go ahead and I turn it back on. Some printers have speakers, some printers have buzzers. If your printer has an actual speaker, you can change the frequency and the duration and control how it sounds. Now, here's where it gets a little funny. The Ender 3 uses what is called the stock Creality display. To use it with this board, you have to let me switch cameras here. To use it with this display, you have to take the black connector that the cable is plugged into on the display board and turn it around on its pins. So you pull it up off its pins, you turn it 180 degrees, you put it back down, you plug the cable back in, and now the Ender 3 display will work with this board. If you don't do that, if you just plug the cable in, you will not get a display. Okay? So, what you don't do is, you don't change the firmware because it's already set to the stock display. Now, had to do the same thing when I put my CR10S board into my Ender 5 because the CR10S board that display is not a Creality display. It is a RepRap Smart Graphics controller. So, just want to let you know, you can run into some issues with the display if you're not careful. But in this case, because it's an Ender 3, you do have some issues with the display. So let me go ahead and go back here. So we're going to go down here. We're going to leave this alone. If you change your display for some reason, to upgrade the display for this board, so let's say you want SD card support, buy a full graphic RepRap controller. It'll plug right into this board. It's got SD slot, a TFT28 or a TFT32. It's got an SD slot. Then you'll want to change these display characteristics. But in this case, we're going to just jump down here, and I'm going to show you where you will turn off the Creality. And you can just search for Creality. I think it's Creality stock display or something like that. Let's see here. CR10 stock display. That's the display that the Ender is using. Okay? So that's what you have to do. Now, the rest of this, you don't have to do anything to. There's some extras here for controlling the fans, if you got fans that make noise and what have you. If you're using the Skein Forge slicer, don't know why anybody uses that anymore. There is a fix here that it's usually commented out. You got some LED driver strips that you can hook up, make things look pretty. Or actually, the thing that really is cool is setting an LED strip to tell you what the temperature of the hot end is. If it's up to temperature, if it's cold, if it's ready, if it's done, that kind of thing. There's some cool stuff you can do with LED strips, NeoPixel strips. Let's see. Servos. Sometimes you want to have servos, and I think we're at the bottom of the file. Okay, now the other thing that you're going to want to do is, once you get through this, we're going to go ahead and save it. Going to go to the Configuration Advanced tab, and we want to go to, let's see, I think it's Advanced. Let's just search for Advanced, because I believe let's see, that's Linear Advanced. Actually, Linear Advanced you probably want to enable. Let's see. Oh, that okay. So let's just jump back up here. We'll go through this. There's not much here that you really want to change, but it's good to know where stuff is. So here's the thing for a heated bed kit, hysteresis if you're having problem with your bed heating, thermal protection for the hot ends. If you're having problems with your hot end, typically you're going to run into issues with either the hot end not heating up fast enough, or something's not changing fast enough. And so typically you'll want to come in here and change your thermal protection hysteresis. And you may have to change the period. So like in this case, for 40 seconds, if it hasn't changed in 4 degrees, it's going to do something. Okay, for the hot end. And here's one for the let's see, what is this? That's for the bed. That's also for the hot end. All right. Here's for the bed. Watch period is 60, and the watch bed temperature is an increase of 2. And then here's for the thermal chamber that we went ahead and turned off because we don't have a thermal chamber. Then there's the PIB bed temp, and then here's the auto temp. All right. Now let's see here. Extruder run out, prevent. Now, oh, okay. Let's see. There is a place that you have to be careful with in terms of your extruder. Let me see if I can find it. There's the fan settings. Let's see. Just looking for the settings that I want to show you in terms of the filament change, because it can cause a problem. Backlash, calibration G-code, microstepping. Sorting of the SD card names. Let's see. USB flash drive support. If you have a way to connect a flash drive to your board, you can do that here. Firmware update. Now, here's a setting that I typically do. By default, Marlin has this enabled. I commented out. This gives us a highlight bar in the menus and on the frame of the display. I find that the hollow frame and the hollow highlight bar make it hard to read. But that's just me. I want to see those particular areas inverted so that the background is white and the lettering is black so that I can see it. This is where you set it. XYZ hollow frame, that's going to be on the front screen. And then the menu hollow frame, that's going to be the highlight bar for your menu selections. Okay? By default, these are enabled. I disable them. Now, we can use a bigger font if we want. Uses more memory, of course. In this case, we have the more memory. Not a big deal. Let's see. Let's see, some graphical things for animation of the status screen. Marlin logo. There's actually a game. Marlin Breakout, Marlin Invaders, Marlin Snake. You can play games on the printer. All right. Now, the next one you want is baby stepping. If you have a probe, you want to use baby stepping. So this is by default. This is disabled. Go ahead and enable it. Then you can enable double click for baby stepping, and you want to also set define baby step Z probe offset. What that does is if you set your baby stepping while you're printing, it's going to automatically adjust your Z probe offset configuration and save that new value to the Z probe offset. I typically allow it to do that. And here is a graphical overlay to show you which direction to baby step, up or down. By default, that's usually turned off. Now, let's see here. Linear advance. I'll turn that on. Now that we have memory to do that, you will have to go through and configure it. By default, I believe there's a default configuration, the K value. We can default that to 0.22. You'll definitely want to set that. There's a test that you can do to do that. There is a setting in Cura for linear advance. I believe you have to enable it. All right. Now, mesh bed leveling or auto bed leveling. These are the offsets for the mesh insets. And then these are the commands that are sent for the G29 commands for probing. You can make that say what you want. Now, in order to save memory on the Ender 3, we typically disable ARC support. And actually, I don't know of any slicer that uses arc support anymore, so you might as well. By default, this is enabled, so you want to disable this to save some memory. And let's see here. Steps per segment, stepper delay, stepper pulse. All right. Memory buffers, you don't want to monkey with any of those unless you really want to. Retraction and tool changing. Okay, here we go. Advanced pause. By default, this is commented out. You want to uncomment this and use it. And so, because this is used by filament change. Now, filament change. If you're using a Bowden setup, by default, this value, filament change unload length, is usually set to 100. That's not long enough to pull the filament all the way out of the Bowden tube. If you set it high like this, I have it set to 500 so it comes all the way out of the Bowden tube, you're going to get another error saying that you've exceeded the max extruder length. And so then you have to change the max extruder length to 500 to match this. Okay? So that's how it works. And then, of course, you have different speeds for the lengths. So there's the slow load length and the fast load length and the purge length. So after you've loaded your filament in, it does a purge. It's going to purge another 100 millimeters of filament. And then the extra distance to resume. All right. The unload retraction, what happens to it pushes the filament in and then it retracts it. That's how you adjust that. The pause part nozzle timeout. I set this to 120 seconds because the default is just too short when you're changing filament. And then 10 beeps. All right. Those are the big changes that I make to this file. Everything else, let's see what we got here. Do we have anything for the TMC 2100s? Let's see. TMC 2208. These are going to be settings for your microsteps. And you may or may not use some of these. Stealth chop mode, if you're using drivers that support stealth chop like the 2130s or the 2208s. Let's see, do we have anything else here? I don't see anything else. And then, sensorless homing. Some drivers allow that. That's a 2130 only. All right. All right, so the rest of this is pretty straightforward, simple stuff that you're not going to monkey with. But the big one was the the advanced park feature. All right, so at this point, we want to compile this for the board. So the first thing we're going to do is we're going to make sure that the board is set. So we're going to go to the Tools menu and we're going to go to the board. And this is an Arduino Mega 2560. And it's an Arduino 2560 Mega processor. And it's on port 14. Make sure that that's checked. Okay? So if we go here, there, port 14 is checked. Or whatever port is your port. Now, typically people will just hit the check mark. I don't like using the check mark for this reason. If you hit the check mark once, it's done. The next time you have to hit the check mark, it's not available. Okay? So I typically use the menu. Menu, you can either do a Control R or you can hit the menu, verify, compile. So we're going to verify and compile. And we're going to go ahead and compile all of our settings in this configuration. And I'm going to show you another step that you want to take when this is done. So this is going to take a moment. If you have any questions about this stuff, post it in the comments. Send me an email, 3dprintingtexan@gmail.com. I'll be glad to answer any questions that you might have. It may take a little bit to get back to you, but I will find the answers for you. I like doing this stuff. I like helping people with their printers. And so we're going to go ahead and I'm going to go ahead and transition back to the other camera. So I like doing that. It's what I do all day long is I help people with their printers. I don't make any money at it. If you want to throw money my way, that's fine, or parts or boards or whatever. Printers. Hey, I will review printers if there's a manufacturer out there, but I'm going to tell you this right now. I don't candy coat anything. I give people the straight skinny, the good, the bad, and the ugly. And I don't care where the printer comes from. I buy my own printers. If somebody wants to give me a printer to review, that's fine. But you're going to get an absolute honest review. That is my integrity. That's what I do. If you don't want that kind of review, don't send me a printer, because I will be brutally honest with the printer. Okay? So just know that up front. If you want to send me a printer, that's fine. I'll build it. I'll test it. I'll give it a fair shot. But I will explain to people the good, the bad, and the ugly. Just like Clint Eastwood. Because I'm the 3D printing Texan. And I don't shoot from the hip. So let's see what we got here. It's still compiling the sketch. It's going to take a little while. And in a moment, we will, once it's done compiling, if we don't get any errors, thank God, then we will upload it to the board, and we will be ready to go with Marlin 2.0 on the MKS Gen L board and be ready to plug it into the Ender 3, which will be in the second half of this video. I'm going to put both these videos together, and it's going to be a long video, so after the board is flashed, we'll take a break, and you can stop the video. You can come back later on when you're done doing your flashing. The nice thing about it is this board shouldn't need a bootloader. So, but if it does, it does. You know, if for some reason you end up with a board that doesn't have a bootloader on it for whatever reason, putting a bootloader on is easy. See my other video. I'll put a card on the screen up here, or up here, up here, up here. Whichever way it shows up, never can tell with YouTube and looking at the cameras. So, but so far, everything is going good, swimmingly, and it's still compiling. Takes a little while. We've enabled a lot of stuff here compared to what was enabled in the printer. And that's the beauty of upgrading this board in an Ender 3. Hey, we got a successful compile. We're done compiling. And let me switch back here, and this is the message that you get. Sketch uses 153,480 bytes, 60% of program storage space. Maximum is 253,952, and the global variable space here, maximum is 881.94. Okay, so we have a successful compile. We're ready to do the upload. So, once again, rather than hit the upload button, which is the arrow button here, because if you click upload and you get an error, and then you go to click the button again, the button's not available. Okay, it's just a bug in the Arduino IDE. I would much rather just use the menu and do an upload or Control U. So we're going to go ahead and we're going to upload it, and let me switch to another camera. Switch to this camera, and you can see what's going to happen with the board here. We're going to see some flashing lights somewhere. There we go. It's sending to the board. Now you see a red and blue LED right there in the corner, and then we have a little green LED down there that's telling us that we are communicating with the USB port, and it is sending the firmware up to the board right now, and That's just going to take a moment to send that to the board, because now we are at 250,000 baud. It's not going to take that long. It's pretty quick. And then I'll log back into Pronterface and show you what the board spits back at us now for parameters to tell us what's on the board. All right. So it says it's done uploading. The lights are finished flashing. Now I'm going to go ahead and minimize. I'm going to go ahead and get out of. Actually, we don't even have to go into Pronterface. We can use the Arduino IDE to show us what we need to show us. So if we go here to the Tools menu, this is another little trick. So if you don't have Pronterface and you do have the Arduino IDE, you can do this. You can go here to the serial monitor, and that's going to open up another window right here. And down here at the bottom, there is a baud button, and you're going to change the baud rate. Ooh, let's see here. Do we not have... Oh, there it is. This thing will go up to 2 million baud. That's pretty wild. So here we have... we selected 250,000 baud. I'm going to switch over my screen here. So right down here, because you couldn't see that a moment ago, there's a little pull down here that will pop up, and Creality by default uses 115,002. We want 250,000 right here. So that's going to pop that up, and then as soon as you connect to the board with the right baud rate, it's going to spit out echo Marlin bug fix 2.0.x, last updated by this author. And let's see, is there any more? Yep. And then the last compile is today, May 23rd, 2019. And then the EEPROM and the Marlin version and the default settings are loaded. Now, if we, let's see, go up here to the entry field at the top of the screen, and we type M115, enter, this is going to give us a bunch of parameters that are defaulted in the firmware. Serial transfer, binary transfer, EEPROMs are enabled, volumetric printing is enabled, auto report of the temperature, print job counting is enabled, auto level is enabled, the Z probe is enabled, all this stuff is enabled. Okay? So, and then if there was more to tell us, it could tell us. So, for example, if we say M502, that loads the default settings. And then we say M501, that makes the oh, you know what? We have to clear the EEPROM. Let's see. M501, all right, and then M503. Here is our default parameters. Units are in millimeter, units are in Celsius, and then the filament diameter is 1.75. The E-step setting here, M92, X is 80, Y is 80, Z is 400, E is 95, and then here's some other settings, and all of these are in the firmware already. Okay, here's our PID temperature settings, here's our Z offset, and this is our filament change length right here, load and unload. So. And these are the commands that you can use to change these settings as well. So, like for example, M420 S0, that's for our enabling bed leveling, and right now it's turned off. All right. So at this point, we're ready to put this board let me transition back over here. At this point, we're ready to put this board in the Ender 3. I'm going to take a short break and get things set up over here on the workbench, and probably have some different camera setups. Excuse me. And see if we can't get this board installed in pretty short order. I mean, we've already got it in the case. There's not much really to hooking up the wires and what have you, and then of course testing the printer to make sure that it's working okay. So at this point, we're going to take a short break. I'm going to edit the video a little bit later, and we're going to move forward with putting this board in the Ender 3. Okay, I think we may be ready to do the second half of this video. I've had to change some of the lighting, so it may be a little bright for YouTube right now, but we'll get through it. I've got some other cameras set up here, some other shots, and then I've got another little camera set up so we can take some close video, and we'll see how that goes. But we're ready to put the MKS Gen L board into the Ender 3, and so this is going to be fairly quick. You know, it's not rocket science to hook up a bunch of wires and get stuff going. The hard part's already done. We've already flashed Marlin, and so let's get started. So I'm going to switch camera angles here and go from there. So this is our wide angle shot, and this is where you'll see me working on the printer. I will try not to keep my backside to you. The problem that I have is I'm limited in terms of the length of the cable for my camera. So at this point, until we can rearrange our desk, our desk and our workspace and what have you, I have to work on the printer where it normally sits. So, but we'll get through it. I got some other video. You see that little orange Sony camera? It's set up to take close-up video, and we'll just go ahead and intersperse it in as needed. So that's how we're going to do it. So I'm going to jump over there to the workstation. Now, fortunately, I have a wireless microphone, and let's see, I'm going to have to adjust the camera a little bit, shouldn't I? So let's pop this up just a little bit, excuse my hand, and a little bit more probably. Let's see where we go. This is a Zoom Q2N camera. It's normally used for my music stuff. And so we're going to enlist the aid here as we can. Now, what I have to do real quick is I have to implement a little known technique for multiple camera setups to synchronize the video. And once I do this, then it just makes it real easy for video editing. But what you do is you take your cell phone, and I've got it set so that we're going to start the record on this camera as well. This is recording to a memory stick. And so I'm going to place the camera where both cameras can see it, the cell phone rather. And I'm going to take a flash picture. So this is how you synchronize video. It's much easier to do it this way than it is to synchronize with audio. So because synchronizing with audio is a little iffy. So I'm going to turn on my flash, and I'm going to set the cell phone here where it can be seen by both cameras, And let's see, can I trigger the shutter? Let's see if I can tap that. There we go. And now both cameras have seen the flash, and I will be able to synchronize the video in post-production. Now, that being said, I've got the Ender machine turned off. Let's see, did I remove the filament or not? I meant to. I guess what I'll do is I'll cut the filament and I'll pull it out later. So let me come over here and get some nippers and just cut that off and pull that roll of filament out. This is, I only mention this because this filament is crap. Like I said, I don't candy coat stuff. If I'm going to review something, I'm going to give somebody an honest deal. And so here's the deal. This filament is junk. It's Maker Geek's Crystal PLA, and it's just really trash. I use it for test prints. I'm going to come over here and I'm going to switch the camera. So, Maker Geek's Crystal PLA. I got this in the Geek box, what they called the Geek box. And I use this for test prints, for like when I'm designing and I need to print stuff and I know it's not going to come out right, but I need to see how it's going to come out. This is the stuff I use. It's junk. So I'm just going to set that up there on the used filament spool stack. Now the first thing I'm going to do is I'm going to start disassembling the Ender 3. First thing is unplug it from the mains. And I have a Raspberry Pi and a camera plugged in. So I'm going to unplug those. Like so. And then I'm going to take my camera mount off. I'm going to have to print another one of those Y pulley covers because I broke that one. And set the camera down here. And I'm going to take the back little end cap off the Ender. And did I not get that on there? Right? There we go. Okay. So this is my Raspberry Pi in my box that I designed that slides into the rails on the Ender 3. Just going to set that there for now. And let's see. The first thing we're going to do is take off the SD card extension holder. And I'm going to go over here to this side. And I'm just going to start unscrewing screws. So we got that one. And we got that one. So there's those two. Put them down here on my little work surface. And then we're going to pull off the cable that we use for the Raspberry Pi and set that over there. And we're going to unplug the SD card extension cable that I have, and we're going to set that over there. These parts will probably not be used on the new installation. All right, and so then now we've got, let's see, can we move this around a little bit to get a better angle? There we go. Now we're going to take off the screws that hold the fan shroud on. And this fan shroud won't be used again either. Let's see, is this the right size? Nope. Oh, was it? Yes, it was. Okay. Now, what I typically do on my Creality printers is I change the screws. I don't like those rounded head hex screws that they usually use on the printer. So what I do is I change them to cap head screws. And I'll put a link to the supplier of the screws that I use. So there's the screws that I use. You see they have these little kind of round, thick heads. Those are cap head screws. And so I use those. I typically replace as many of those screws as I can in terms of the printer. So we got a little bit of dust there. And I'll set these screws down here on the workspace so we don't lose them. Now, the Ender 3 printer has 2 screws in the front on the top, the 2 screws here on the extrusion on the front, and a screw underneath the bed in the back. Just very gently move that bed, and then you can get at that screw in the back. And if I had another camera, I actually have another camera. I should go upstairs and find it. I think it's upstairs. And at some point enlist its aid in creating these kinds of videos as well. Because I think I have another tripod around here too, somewhere. So so that gets us the top cover off. So we're gonna lift that cover off, and be careful because there's a fan connection there for the stepper cooler fans, and we'll probably use that fan again. So just unplug it from the board, real easy. Then the next step is to unplug the display adapter cable and just kind of hang it over the top of the extrusion. And you'll notice that Creality has all the hot glue stuff. And I'm going to go ahead and switch the camera back over to this other camera. There we go. It's nice having a deck on the tablet, so I can just tap the button. Actually, I could move the tablet a little closer, make it easier, because I will be switching kind of back and forth as I need to. So let's kind of just set that there. So the tablet connects via Wi-Fi to the computer, which is running, in this case right now, Open Broadcast Studio, which is controlling all the cameras. It's an interesting setup. I usually use a product called vMix, but in order for me to get the functionality out of vMix now that I really need, they want to charge me $200 for the upgrade, and I don't have $200. But OBS will do for now. So now we've got our Sony webcam over here. This Sony camera is a great camera. It can't be used as a webcam anymore because the drivers don't exist for Windows 7, Windows 8, Windows 10. They stopped making the drivers at Windows XP. So now I just record to the what the hell do they call those cards? Memory stick, and go from there. So what we have here, and I'm going to just kind of move this camera up a little bit and shine it down into the board, and we'll cut to this video. What we have here is we have the BLTouch on a pin 27 board right here, and let's see, can we get so right here's the pin 27 board, and let's see, right there we go. Right there's the pin 27 board with the BLTouch connection, and then of course we have our various connections that are used by the printer. We're going to take all of these off and reconnect everything on the Gen L board. So I'm going to set this camera back down. Unfortunately, we just can't use that camera much for showing detail. Maybe I'd be able to get into the shot a little bit better. Let's see if I can figure out how to arrange the feet on the tripod. Oops. Without them collapsing so much. There. All right, now can we see into there? All right. So here we have your Z motor stuff and XYZ and the extruder, and then over here we have the power and the fans and the various thermistors and bed heating and what have you. So the first thing we're going to do is we're going to detach the BLTouch, and we're going to detach the pin 27 board. I'm going to take that, I'm going to put it over here out of the way, and I'm going to go back to, let's go back to the main feed. And so now the other thing that we have to do before we get too far, well, let's just unplug some stuff. Now you have, in many cases we have hot glue, because for whatever reason, Creality really likes to use hot glue. So let's see here if we can get some of these things loosened up. Have to peel some hot glue off of there. And in some cases it's easy, and in some cases it's not so easy. Let's see. Depending on how much hot glue they've used. Let me get an X-Acto knife. Have to be very careful using these X-Acto knives. You can really hurt yourself. But I guess they put all this hot glue on because they're afraid of stuff coming out apart and shipping. All right, so there's our first thermistor wire, and I'm not sure which one this is yet. I don't know if it's the hot end or if it's the bed. So, but let's see. We're going to have to find a way to mark that because I don't know. I'm going to use a Sharpie to mark that one because I'm not sure which one that is yet. So let me just reach over here and get a Sharpie. And I'm going to put a little hash mark on the wire so I know which thermistor that is when because I know which connector it is when I take it off the board. And there's the other thermistor. And then here's the ZN stop that goes to the BLTouch. And then the other connectors, the other connections are labeled. You know, just I got some more hot glue here to deal with. I'm sorry for my hands in the shot here. Let's see, can I see if I can get some leverage on this hot glue with some pliers. There we go. They really glue that stuff in there. Big old globs of hot glue. All right. Trash cans over there. That's why you keep seeing me throw stuff over there. All right, so we have our, this is our YN stop with more hot glue on it. And then our XN stop. Whoop! What the hell happened there? Pulled the connector right off the board, the housing, the little white housing that goes around the pins on the board. All right. And then we have our fan that we can, our part cooling fan. That's got a bunch of hot glue on it. They really didn't want this stuff to come loose in shipping. That's got that big old glob of hot glue on it. That's gone. And now I'm going to put this little white housing back on, like so. All right. Now at this point we've got our end stops unhooked. Now we'll unhook our extruder motors. Once again with the ubiquitous hot glue. See if we can get some of this stuff off of here, because we don't want it causing problems afterwards. Getting pretty good at hitting the trash can. Not bad for a one-eyed man. All right, let's see what we got here. More hot glue. And I figured I'd video this stuff in real time so you could see what it takes, what the level of effort is, what have you. And then so that's the extruder, that's the Z, that's the Y. Let's get some more of this hot glue off of the plug. Because hot glue will cause a problem when you're making your connections. So. There we go. Let's pull this off of here as well. You know, one thing I've realized doing 3D printing is this hobby, avocation, whatever you'd like to call it, is darn hard on your thumbnails or fingernails. I just tore my thumbnail. So I thought trimming my nails short for guitar playing was bad enough on one hand, but it seems like I'm always tearing up the nails on both hands now. So it's just seems to be easier to use your fingernails than it is to use anything else. All right, so we got the extruder motor connections done. We've got the end stop connections done. Now we're going to undo the bed heater. I got my little screwdriver right here. So we're going to undo the hot end. And we're going to undo the bed heater. And you know what, I'm going to move this out of the way a little bit, just to get it out of the way. And in case you're wondering, if you're seeing me sweat, it's because it's about 90 degrees in here. We don't have air conditioning here in this house. The landlord is about 80 years old and he wants to tear the house down. And being that I'm retired and my wife is on limited income, we can't afford to have him replace the air conditioner and jump up the rent. So we choose to forego air conditioning. This must be another fan. Oh, it's the hot end fan. Okay. And so in the summertime here in Central Texas, it gets a little warm. And actually, this time of year, we've usually already seen 100 degrees, but this year we haven't seen it yet. So things are a little mild this summer so far. So that's going to get that fan. That's the hot end fan. That's the Z end stop. We don't need that. And then the last set of screws is the power supply. So, see if we can get those out. And these connections aren't particularly hard to get at. It just takes a little bit. So that gets that out. The power supply is out. Everybody's out. Okay, now all the connections to the board are loose. What has to happen now is we have to tip this up. Whoop! I forgot I had stuff there. Hang on. We've got nozzles and some tools and my BLTouch alignment aid and some, let's see, a nozzle drill. Let's see, let's collect some of this stuff up real quick. A couple of little cable clips. I've got some nozzles that I need to put the torch to unclog. A couple of grub screws. Here's my nozzle drill. All right. Is that everybody? Oh, there's a grub screw there. Don't want to lose that one. Is that a grub screw or is that a piece of filament? That looks like cooked filament. All right. So we're going to put those down here on our little work mat. All right. So now we're going to tip the printer up on its side. Got a couple of other little tools here. Filament oiler. And on the bottom of this box, right here, there's another screw that you have to take out. So we take our handy little wrench, Allen key, and hold the box, take out the screw. All right, now that box comes off, just like that. There's our Creality Ender 3 board. All right. And I'll keep that board mounted on there. I've already got screws mounted in the other board, so not a big deal. I'll use this for some other testing purposes. All right. Now, let's get the housing for the new board. And so this is going to go this way. And the USB connection is right here on this side of the board. And this side of the board is going to be closed by the extrusion of the aluminum side. And these two little things here are going to flip up and hold that cover up. And then, of course, we have the fan is going to be here anchored with these screws. So this was why I didn't like this design initially, was because the fan was just going to be hanging down, and the only thing that was keeping it was this little stub of plastic right here that would keep it in place. And so it just didn't seem like the best solution for it. So, and then the other thing that you might want to know is, you know, I have a little escutcheon here. Oop. Are we done with our memory card? I don't know why. I don't know why it stopped recording. Let's see here. Let's see if we can record any more. So I have a little escutcheon here that protects the cabling from the sharp edges of the metal that goes on the extrusion. And let's see what's caught in there. The BLTouch is caught in there. All right. And think that was my phone. Could have been. All right, so that protects the wiring from the sharp edges of the extrusion. All right, so a little print that you can print on Thingiverse. I'll put the link in the description. All right. Now, let's get some of this other stuff out of the way. So that gives us our connections, or cables, what have you, for the Gen L board. Now, what we're going to do is we're going to start hooking some stuff up. And we've got the power and the heated bed, the extruder 0, extruder 1, and the fan. Well, the fan is easy. That's this one. The question is the polarity correct? So let's see here. What is the polarity? Plus, minus. Yellow. Okay, so the polarity is correct. Don't have to worry about that one. All right. For the hot end cooling fan, we're going to go in where the power goes in, because that's 24 volt. We've got the hot end heater element that will get squared away here. So that's going to be extruder 0. So we gotta loosen some screws here. And I'm sorry there's not much to see here right now. We've got, you know what, I'm going to take this lid off for now because we don't need it. We'll put it back on in a little while. That way you can see what's going on. So we've got our extruder 0 connection. We don't need the extruder 1 connection. We've got a part cooling fan. We've got our hot end, our hot bed connection. Let's see, which one is the bed? That's going to be the question. Let's see here. Somewhere, it's not that pair. This pair this is okay, so this is the bed here, the one that I'm pulling on. What happened to my other connections here? I'm missing some connections. Escaped. Let's see. I don't want to have to tear all this. Oh, there they are. Okay. So this is power. There we go. This is power. And our polarity for that is plus minus. All right. So we're going to go plus, oop, we're gonna need our fan as well. Let's see. So here's our hot end fan that's always on. And that's going to go into the main power, because we are limited in terms of power jacks. So that's plus, minus, oh, come back in there. So let's have to do these one at a time, I guess. Plus, I wish I had some ferrules to put on these, because they really should have ferrules on them. Just don't have any. And let's unscrew that some more. All right. Okay, that goes in there, and that goes in there with it. This is going to be a little tricky getting some of these wires and these connections, because there's not a lot of room. There we go. Now make sure when you anchor these connections, make sure that you test the connections. Make sure that they're actually there. Make sure that they're actually tight. So just, tighten down the connection, and then pull on the wire. Just kind of pull it, make sure that it's there. All right, so that's the first one. And then the second one, of course, is the negative for the power supply. And just take your time. You don't have to be in a hurry to do this stuff. It's fairly straightforward. Just it's not rocket science. Just black to negative, red to positive. And hopefully, when you're all done, you don't see the magic smoke. It's kind of the 3D printing joke is the magic smoke. It's not funny, but everybody seems to mention the magic smoke. So let's get, if we can get some of this. Oops. Did I lose that connection? Get some of this stuff in here. So there's that one. And there's that one. I caught it, captured it. Oop, slipped out. Hold on to it. See if we can get the screwdriver on there. Can we get the screwdriver on there? Screw it down. Oh, missed. Do we still have that other connection? Guess not. All right, let's try this again. Put that one in. Put that one in. Hold them there. Hold them. Hold them. All right, now let's see. Are they there? Are they tight? No, that one doesn't look too tight. So let's crank it down just a little more. Okay. All right, that's got them. So that's our power supply connection and our fan. And next we have, right next to it, we have the heated bed. And that is going to be these two connections. And let's see what the polarity is there, because sometimes they switch things around on us on this board. Can we see? Yep, okay. So that's plus minus. Let's loosen our connections. Make sure we have ample looseness on the screws so we can get the stuff into the proper place where the wires need to go. So let's see here. Can we get both of them in at the same time? Probably not, but let's see. Let's try it. All right, we've got both of them. Oh, all right, we got one in. We'll do one. We'll do one, and then we'll get the other one. So there's the negative. All right. And now we'll get the positive. I think part of the problem is that these are somewhat attached. Let's peel them back a little bit. There we go. All right. So let's get the bed heater. All right. Next we have the hot end heater, and those are not polarity sensitive, so you don't have to worry about which one is positive and which one is negative. Although and actually you don't have to worry on the bed either. But sometimes if you have an external MOSFET, you do have to worry about that. So let's make sure our screws are loose and get those connections made. May have to twist these a little bit. Don't want things shorting out. All right, so now let's put that one in there and hold it. And let's put this one come on. I'm fighting with other wires here, getting tangled up. We want to make sure we go in the right place, and we've got a couple of little stray strands here. There we go. Now we're in there. All right, so we've got the hot end. Those are snug. The bed is snug. We don't need extruder 2. And then next we have, oh, you know what we need to do? We need to put on the stepper drivers. So let me come over here and collect up a few stepper drivers that we have sitting here on the desk. Now, there's a couple of pins on the stepper drivers that you have to be aware of. You want to match things up. There's some pins that are labeled EN for enable and GND for ground. So if you can find out where the ground and the enable pin is, you should be able to get these things plugged in correctly. So on the bottom of the board, and I can't take this board out, but I can show you because I have another board. Let's see. Do. There it is. Just so happens I have another Gen L board because I was going to put this board in my Ender 5. But right now the Ender 5 has the Corality CR10S board. So here's the other Gen L board, and you can see that the drivers are already installed on it, and there are little markings on the board on the bottom side that tell you which pins are which. Okay, and so the EN is on this end, that pin. So I just need to know where the EN goes. So EN on this driver is on that end. So we just start plugging drivers in. There we go. Now, on many boards, on many drivers rather, you're going to have a black side and a blue side, or a black side and a green side, or black side and a yellow side. Usually whichever side is the off-color side, that's where you'd put onto the off-color socket on the board. That kind of it's generally accepted to be that way. Just make sure that you get them in the holes, pressed down where they need to be. There. And there. Now I put all 5 of them on, even though one of them is not going to be used. But that's okay. Now, let's see, we'll deal with the BLTouch afterwards, because I have to find out what pins to put it on. But right now, we're going to deal with stepper drivers. So this is Y, which is the blue one. And this is X, which is the red one. Fortunately, these are just same kind of plugs. And then we have, let me get this out of the way. Then we have the extruder, which is going to be the black one for extruder 0. If we can stretch it to make it reach a little bit. Come on. I just haven't broken the zip ties on these wire looms yet. So, and then we have the last one is going to be the Z, and that's going to go into the green one. Now your connector colors may not be the same on your board. So, all right. So that's that, and that. So that's got those. And let's go with the thermistors. Now I got to look and see what the thermistor was that I marked on the old board. Remember I marked it with the Sharpie? So let's see here. That is the, it's hell to be half blind, because sometimes you just can't see. Let's see, that is the extruder temp. All right. That's the extruder temp, and then the other is the bed. All right. So the one that I have marked is the thermistor for the extruder. So that's the thermistor for the extruder. Now we're just going to find out where it is on the MKS board and plug it into the right slot. Just got to get things routed correctly. So the connector that we want there is which one? And I'm going to look at the spare board for that, because once again the writing is too small. TH1, that's the black one. Okay. That's the black one. TH1. So that's going to go if I can get enough light to see and enough cable to plug it in. It's going to go there. And then the other one will go, oops, right next to it, which is the bed, into the white connector. And that one gives us a little more cable. So the white connector is the bed thermistor. So we'll plug that into there. All right, so we've got that. I'm sorry there's not much to see here. My camera fell down. Hello. I'm not crazy about this tripod either. All right, so let's see what we've got besides a mess. So here we have our thermistors are wired up, our bed heating is wired up, so the only thing that's left now is the end stops. The end stops and the BLTouch. So we have two end stops, the X and Y, and I believe, let's see here. Have these got signals or ground? Let me see what we got here. Voltage, ground, signal. Okay. So what we have to do is, in order for these to plug in correctly, we have to plug them in on the two bottom pins of the connector. We don't want the voltage pin, we just want the two bottom pins. And so in order to do that, we're going to have to trim off the little key. So that's the X, because the key won't go, so I just got to figure out which key we have to trim off. So it's going to be the key that's in the center of the connector. All right, so just be careful when you're doing this. As he says, as he slices into his thumb. So just cut that key off. And then we can get into the plug, like so. Same thing with the Y. Got to cut the right key off. And of course my Sony camera stopped recording again, so it must have a time limit on the length of the recording. So let me hit the record button again. All right, now, so we got that key cut off, and we'll get this connector plugged onto the board. This is the Y end stop, and that's going to get plugged onto there. And then the Z end stop, that's going to get plugged onto, let's see, voltage ground signal. So the Z could be an interesting issue, because I believe for the BLTouch the wires are backwards. So we're going to have to switch the wires around for the BLTouch, because the white wire goes to the signal pin and the connector is backwards. So let me get my little monocle out here and push these pins in and see if we can't switch these DuPont connectors without having to redo the DuPont connectors. Or these are JST connectors with same connections, really. Just be careful you don't stab yourself with the X-Acto knife when you're doing this kind of stuff. Oh, come back here. There we go. Now what we have to do is, we took the connector out, and we got there's a little bitty pin, a little bitty edge that you have to push back up, because that's what anchors it into the connector. So we want to make sure we go into the right side, like so. Push that in, make sure it gets captured. Like that. And do the same thing on the other connector. Just a little bit, just with the edge of the X-Acto knife, just pry up on that. Just be careful you don't break it off. Switch it around. Now, the default connections on the BLTouch are DuPont connectors, little black connections. I changed these connectors. That's why I'm having to do this. All right, now I can trim off the key on this connector. Like so. And I can plug that one in to the Z end stop. So that pretty much completes the wiring of the basic Ender 3 wiring. Now, the only thing that's left is to find out what servo pins to plug the BLTouch onto. And let's see. I'll have to find out what servo pins to plug that onto. But I'm going to go ahead and I'm going to mount the box and get this all put back together. So we're going to move this up into position. Like so. And like I said, we've got our little thing, thing here to protect the wires from the sharp edges of the extrusion. We've got to reroute our display cable slightly here, because that's going to come over the other side. All right, so that is coming through there. Is that right? Huh. All right. What is holding us up? Oh, I'm snagged on the bid. All right, that's what's the matter. There we go. That's got it now. That gives us clearance for the USB plug. Now what we're going to do is we're going to put the front screws on first to help us, because that'll help us hold it. That's the wrong size wrench. What did I do with that other wrench? Somewhere around here. Oops, did I drop it? No, I dropped something else. I dropped a nozzle. Okay. All right, so now I got to find what I did with the wrench that I need. Did I stick it back in here? Yes, that's the one. So I'm going to tighten these up. And I really appreciate Michael taking the time to design this box. I mean, if he hadn't done it, I'd have had to do it. So I do appreciate the fact that he did it. I just had to make a few minor changes to make it work better. So I appreciate you, Michael. I don't know if you'll see this video or not, but I appreciate you, Michael. So Michael's channel, if you haven't seen him, is Teaching Tech on YouTube, and he's from Australia. He's a nice guy. I think he's a school teacher. Let's get into the holes here. I don't want to cross thread it. Can we loosen this up a little bit? Get in the right places. There we go. Now, one of the tips that I'm going to tell you is when you're tightening bolts on these Chinese printers, do not use the ball end of the Allen keys. The ball ends are made for quickly screwing something in or out. Use the flat end when you're tightening, because the ball doesn't like being stretched out like that. So now what we've got is we've got our box in there, and then we're going to screw down the top with one of the screws, and screw down the bottom. Actually, we're going to screw the bottom in. Let's see, which way is that going to go? Right here is the screw hole. So we're going to go here. We're going to put the lid back on. And let's see, we got to plug in the display adapter, and I'm going to hazard a guess here that the display adapter is going to go into EXP1. We'll see. We may be surprised. So EXP1 I may have to make a few changes here. And what I did was, when I redesigned this box, I made a change to the hinge so that the display cable would come out through the bottom of the box correctly. So we're going to put that pin up there and put this pin. Can we get it in there? Come on. I'm in one side. And I'm close to being in the other side here. Let's see. Oops, I missed. I had to make the pins a little bitter. There we go. Because the pins kept breaking off. There we go. Now we're in there. Now we can close that up, and we can pop these little snaps into place. And now we have a screw hole here that will hopefully line up with the screw hole that's underneath. And that's going to be another Allen wrench. And the nice thing about this mod is it's completely reversible. If you decide you don't want to do it, or you can't complete it for some reason, or you're of course, finding the cotton picking hole here is a challenge. Am I in? No. All right. Oops. Now this is what I mean about me fumbling around with screws and what have you. Because, you know, being one-eyed and not being able to see, and there's some challenges there. So let's see here. If we can find out where this cotton picking hole is. Let's open that up. It's right there. Okay. Am I not going to be able to get in there? Let's see. All right, I may leave the bottom screw out for now until I can find the hole. So let's set the top screw. So we're going to set the printer back up the top. Move the bed forward a little bit and see if we can find the top screw, because the top screw should be there too. The problem is that these screw holes are down in the slot for the extrusion, and so they're very hard to see. All right. I don't know that I'm going to see them. I don't know that I'm going to get to them. because they're hard to feel. Maybe there's a trick. Who knows? All right, so what I'm going to do is I'm going to fire up the printer without the screws. We've got it turned. We've got it set so that we can deal with the stuff that we need to deal with. Now, the other thing that I need to deal with is the connector here on the Ender display. Since we're plugged onto the back of, and we're plugged into EXP1 on the board, let's unscrew the display, because what we have to do is we have to turn a connection around on the Ender display. There's a little black plastic piece of housing that indexes the cable so that you can't plug the cable on the wrong way. And that needs to be turned around to make this display work with this board. If we turn on the printer right now, we'll get no display. So what we have to do is we have to take this connector off and turn it around. So let's see if I can do this with my needle nose pliers. This connector just pulls straight up off the board. It's not glued on or anything like that. It just can be a little bear to get to. I may have to take my little cover off here. Naturally, that's a different size wrench. Let's see which one are those? Is that the right run? Yeah, that's it. So we just got to take this little plastic cover off that I put on the back and change that little cover around. Let me come over here and sit down and do this. Let's see. I don't know what happened with the video, but for some reason my screen deck switched to my microscope feed, so I'll probably you'll probably see an awful lot of the other camera. So, but now we're back to let's see. Now we're back to this feed. All right. I'm sorry. This could be interesting with that other camera. I hate these screws that they use on this. These are just the factory round head Allen key screws that are used. Let's see, I got 3 out of the 4 done. Let's get this 4th one done. Oops. Sorry, Lucy. Lucy's my dog. She's laying down here at the feet. All right, so that gets that done. Let's pull this connector off. Get a little screwdriver here to help me pry it up. There we go. So basically what we're doing is we're just taking this connector off the display. Let me hold it up here to the camera. It just pulls off the pins. It's on tight. You have to work at it to get it off. Just be careful you don't break any pins. All right. So now you can see here's the pins for the display adapter. And this is the connector, and you see the indexes are pointing towards the edge of the board. So we're just going to take this piece of plastic, we're going to turn it around, and we're going to pop it right back onto the pins and push it all the way down again. And then we can plug the cable in, and we should get a display. So let's try that. Are we still recording over here? Yes, we are. All right. So we're going to take this, and we're going to plug the cable, the display cable. Where the hell did it go? There it is. And we're just going to plug it in backwards, well, keyed. The cable is backwards, but it's keyed. And we're just going to set the display here to the side. And I'm going to take a short break. I'll be right back. Our display is a little iffy. Don't know why. Could be something going on with the board. But the display is lit up, so we know that that's working. Could be some kind of a loose connection. So I'm gonna have to deal with that. Let's shut it down. I see stuff going on. So I may have to reflash something here. Let me make sure everything is set. It could be that we don't have a ground connection on the printer. So, and that's quite possible. So what I'm going to do is I'm going to screw some screws back here in the back. And because that's what it was acting like. It was not getting grounded properly. So we'll just pop a couple of these screws in and pop the display back onto the printer with some other screws. If I can get some of these cutting picking screws out of here. This is one of those crazy prints. Captures the screws. Come on, get out of here. Son of a gun. Let's see here. Now I know that that screw should come out. Come on, just push out of there. And I know this one should push out too. There we go. We just need a couple of them. So I'm gonna mount these screws here so that the board gets grounded. And I'm sorry, I was focusing on the screws and stopped talking. So we're just going to get these tightened up here and attached to the printer so we can ground the printer. And hopefully there'll be a, because it was acting like it was a ground, an issue with ground. The characters were all jumbled up. So let's go ahead and plug these screws in. Plug the connector back in. Like so. And put that on the front. Screw that in. Did I miss that screw hole? I sure did. Where are you? Right there. All right. All right, so we've got a screw in there. We should have enough ground. We've got the cable in. I'm pretty sure the cable's all the way in the bottom side. Let's turn it on and see what we get. And the screen is still garbled up. However, it shows the correct display. Thermistors are reading correctly. And then it goes crazy with some Chinese characters and what have you. So there's definitely something going on here. But it's running. It's working. This is a display adapter issue. So let's see. Let me, just for the heck of it, let me shut down. And I'm going to go to the EXP1 connector. Just for the heck of it. See, the EXP1 doesn't show anything. So, do we have to turn the connector around for the EXP1? Maybe I have the wrong connector turned around. That's entirely possible. So let's try that. Let's turn that connector around. So maybe it's supposed to be the EXP1 and not the EXP3 connector. We'll see. Whoop, whoop, whoop. Don't break it. Don't break it. Yeah, gummit. I broke it. So I said you got to be careful with these connectors. I mean, it doesn't necessarily have to be keyed, but it's nice to keep it keyed. Just pry it up a little too hard, too fast. All right, but the connector's still good. All right, now let's plug the connector onto that particular pin. See what we get. Turn her on. No connection. All right. So I guess I'm going to have to find out, get back online and find out exactly which connector, which cable, because this is a single cable display that we have to use. Maybe I need another cable. Maybe I need both cables. Who knows? Let's try the third cable just for the heck of it. That's definitely not it. Okay. So this one definitely produces the display that we need. It's just that it's not correct. So, and it could be just a setting in firmware that I have to reflash. So, all right, I'm going to shut down this video until we can get it squared away. I will post another segment on YouTube for this project. Until then, this is not rocket science, and my cat has taken over my desk again. All right. My name is Ben Brady. I am the 3D Printing Texan. I'll see you soon. Okay, everybody, as promised, I figured I would give you a little bit of update on the progress that we made with the Ender 3. You can see it's working back there in the background. We got a display going. Let me tell you what we did. We did just like Michael did in his video back at Christmas time in Australia. It turned out that I had to use two cables to hook up to the EXP1 and EXP2 ports on the board and then to the display. On Reddit, there's a bunch of conversation about using one cable. Now, I had one cable plugged in. It did display the display, but in pretty short order, it devolved into all kinds of garbage characters on the screen. So I have a RepRap full graphic display sitting here on my table. So I took both of those cables off of that and plugged them in, and the display worked fine. Then the other issue was just getting the BLTouch to work. I had to figure out what servo pin to use, and so you use servo pin 11, which is the bottom set of pins on the servo board. On the servo pins section, it comes out servo 0 is equal to pin 11. And so you just enable pin 11 in your firmware, and in the BLTouch section where it says servo 0 pin 11. And so it was very easy, straightforward, and so I've got it running here in the background. We've got it hooked up to Octoprint. We do not have the TFT display hooked up yet, so I do not have SD card support, so I can't run an SD card, but I'm running through Octoprint and it's fine. And I'm running at 250,000 baud. So the MKS Gen L board is a very good board, and I'll tell you that the TMC 2100 drivers, the thing is just so freaking quiet. All you can hear is the fans. The thing, I mean, you could run this thing in a cemetery and you couldn't hear it. It's just super, super quiet. I really had to question, is this thing running? But yes, it really is running. The loudest thing is the fans now. So, matter of fact, my wife, she said, "Wow, that's really quiet." And so now I have another Gen L board with 4988 drivers because that's what I could afford. But I bought these 2100s just on a whim. They were fairly cheap. I did have to go in and set the VREF voltages on them. VREF I set to like X, Y, and Z. I set it to 0.76, and the extruder I set to 0.9. So that's what the calculations came out to be. Pretty straightforward setting the VREF on those drivers. So that's the upshot of it. The ender is now converted, and we're going to do another video when we do the TFT 28 screen. So for now, that's all we have. My name is Ben Brady, and I am the 3D Printing Texan.